Hello my dear students, welcome back to chemistry class. Today let us continue the lesson, Is matter around us pure? So let us discuss what we have learned in the previous classes. We have learned what are pure substances, what are mixtures, and two different types of mixtures, homogeneous mixture and heterogeneous mixture. Then we learned what is meant by a solution and its properties and examples also. Then what is a concentration of a solution, how to express it, and what are saturated and unsaturated solutions, what is solubility. Then we learn what is a suspension, its properties and examples also we learned. Then what is a colloid, its properties, examples, different types of colloids based on the states of dispersed phase and dispersion medium. We have different types of colloids. Their examples also we learned. Then we compare the solution, colloid and suspension. Today we are going to discuss a few textbook questions and answers. First question. Pragya tested the solubility of 4 different substances at different temperatures and collected the data as given below. So results are given in the following table. In this table, the results are given as grams of substance dissolved in 100 gram of water to form a saturated solution. For example, the potassium nitrate, one salt is potassium nitrate. At 283 Kelvin, 21 gram of potassium nitrate is required to dissolve in 100 gram of water to make a saturated solution. According to this table, at 293 Kelvin, how much amount of potassium nitrate is required to make a saturated solution in 100 gram of water? It is 32 gram. At 313 Kelvin, 62 gram of potassium nitrate is required to make a saturated solution in 100 gram of water. Similarly, at 330 Kelvin, it is 106 gram. 353, it is 167 gram. And you know already what is meant by solubility. It is the amount of solute present in a saturated solution at a given temperature. For example, here at 283 Kelvin, the solubility of potassium nitrate is 21 gram per 100 gram of water. So, same way, here 4 salt solubilities at different temperatures are given. 283 Kelvin, 293 Kelvin, 313 Kelvin, 333 Kelvin and 353 Kelvin. Potassium nitrate, solubility of potassium nitrate is given at these different temperatures. Then solubility of sodium chloride, potassium chloride and ammonium chloride are given in this table. So based on this table, here a few questions are asked. Let us try to answer these questions. First one, what mass of potassium nitrate would be needed to produce a saturated solution of potassium nitrate in 50 grams of water at 313 Kelvin? So, according to this table, at 313 Kelvin, how much amount of potassium nitrate is required to make a saturated solution in 100 gram of water? It is 62. It is given in this table, 62 gram is required. So based on this, we have to calculate how much potassium nitrate is required to make a saturated solution at this temperature, that means 313 Kelvin, in 50 grams of water. So let us see how to calculate this. So it is given, the given data is mass of potassium nitrate needed to produce a saturated solution of potassium nitrate in 100 grams of water. According to the table, it is 62 gram. So here we have to calculate mass of potassium nitrate needed to produce a saturated solution of potassium nitrate in 50 grams of water. How to calculate? In 100 grams of water, the mass required is 62 gram. So in 50 grams of water, how to calculate? 62 divided by 100 into 50. So mass of potassium nitrate needed to produce a saturated solution of potassium nitrate in 50 grams of water is equal to 62 by 100 into 50. So you can use the method of cross multiplication here. So we are getting the answer 31 gram. Next question. Pragya makes a saturated solution of potassium chloride in water at 353 Kelvin and leaves the solution to cool at room temperature. What would she observe as the solution cools? Explain. So at 353 Kelvin, she prepared a saturated solution of potassium chloride. So as we have seen here, 54 gram of potassium chloride is required to produce a saturated solution at 353 Kelvin. So as the solution cools, what happens? When the solution cools means temperature reduces, this 54 gram is not required to make a saturated solution. So what will happen? Some amount of potassium chloride, it will get separate out as crystals. Let us see the answer. So some amount of dissolved potassium chloride will separate out in the form of crystals at room temperature because the solubility of potassium chloride decreases with decrease in temperature. Next question. Find the solubility of each salt at 293 Kelvin. Which salt has a highest solubility at this temperature? So, solubility of each salt at 293 Kelvin. Potassium nitrate, it is, so this solubility is given per 100 gram of water. Potassium nitrate, it is 32 gram per 100 gram of water at 293 Kelvin. Sodium chloride solubility is 36, potassium chloride 35 and ammonium chloride 37. So, which is having highest solubility? Ammonium chloride. Next, what is the effect of change of temperature on the solubility of a salt? So we can see in this table, as temperature increases, what is happening here? The amount of solute required to produce a saturated solution also increases. That means as temperature increases, solubility also increases. So let us see the C and D answers. As we have seen, solubility of each salt per 100 gram of water at 293 Kelvin is potassium nitrate 32 gram, sodium chloride 36 grams, potassium chloride 35, ammonium chloride 37 grams. So which is having higher solubility? Ammonium chloride. The answer for D, the solubility of salt increases with increase in temperature. Next question. Write the steps you would use for making tea. Use the words solution, solvent, solute, dissolve, soluble, insoluble, filtrate and residue. So all of you will not be having the same answer for this question. What is the reason? The way you are making the tea, it is different. How many of you know how to make a tea? Those who don't know, you can discuss with your mother. So each one will be having different methods to make a tea. So based on that, you can write the answer, but you have to include all these terms in your answer. Solution, solvent, solute, dissolve, soluble, insoluble, filtrate, residue, etc. So some will boil the water first. To that milk, sugar, tea leaves, all this will be added. Some will boil the milk, to that tea leaves will be added. After boiling, they will filter. To the filtrate, they will be adding the sugar. So each one of you will have different methods to make the tea. So let us see one answer here. First, water is taken as a solvent in a vessel. This water, that means the solvent, is allowed to boil. During heating, milk, tea leaves and sugar are added to the solvent as solutes. They form a solution. As sugar is soluble in water, it gets dissolved, but tea leaves do not get dissolved because tea leaves are insoluble in water. Then the solution is poured through a strainer. The insoluble part of the solution remains on the strainer as residue. The filtrate is the required tea. So this answer, based on your method of preparation, the answer may vary. Next question. Which of the following materials fall in the category of a pure substance? So already have studied pure substance means that contains same type of atoms or molecules. So it can be an element or a compound. So an element means the element, one element, a particular element that contains the same type of atoms. A compound means that contain same type of molecules. So for such questions, how you have to select the answer? You select element or compound. They are the pure substances. For example, in this question, ice is a compound. You know its molecular formula is H2O. It contains all the molecules are H2O molecules. So that is a pure substance. Milk is a mixture. So that is not a pure substance. It contains different types of substances. Iron is an element. It is a pure substance. Hydrochloric acid also a pure substance as it is a compound. Calcium oxide is a compound. It is a pure substance. Mercury is an element, so it is a pure substance. Brick is a mixture of different types of substances. Wood also a mixture. Air also a mixture. So let us see what are the pure substances among this: ice, iron, hydrochloric acid, calcium oxide and mercury. Next question. Identify the solutions among the following mixtures. You know what is meant by a solution? It is a homogeneous mixture of two or more substances. So here soil is not a homogeneous mixture, so it is not a solution. Seawater is a homogeneous mixture, so it is a solution. Air is also a homogeneous mixture of different gases, so it is a solution. Coal is not homogeneous. Soda water is a homogeneous mixture, so it is a solution. So let us see the answer. The following mixtures are solutions: seawater, air and soda water. Next question. Classify each of the following as a homogeneous or heterogeneous mixture. Soda water, as we have seen already, it is homogeneous mixture. Wood is a heterogeneous mixture. Air is homogeneous. Soil is heterogeneous. Vinegar, you know, that is a mixture of acetic acid and water. So it is a homogeneous mixture. Filtered tea also a homogeneous mixture. So let us see the answer. Homogeneous mixtures are soda water, air, vinegar and filtered tea. Heterogeneous mixtures, wood and soil. Next question. Which of the following will show Tyndall effect? So you know what is meant by Tyndall effect? The scattering of a beam of light by the colloidal particles is called Tyndall effect. So in suspension also, some of the suspension will show the Tyndall effect. But solution, as the particle size is very small, solutions do not show Tyndall effect. So you have to select the colloidal particle among this. Salt solution, it is a solution, it doesn't show Tyndall effect. Milk is a colloid, it shows Tyndall effect. Copper sulfate solution, as it is a solution, it doesn't show Tyndall effect. Starch solution is a colloid, it shows Tyndall effect. So let us see the answer. Milk and starch solutions will show Tyndall effect. So by this, we have completed one part of this lesson. The remaining part, it contains separation of different types of mixtures, then about elements and compound, physical and chemical changes, all these. So that part will be discussing later. So till how much we completed now, learned properly, the remaining part of the question answers will be given today. Complete your classwork also, and you will have a class test of this lesson till how much we completed. You will have a class test on next Monday. Prepare well for that. Thank you, children.